And welcome back to problem 6 of the Marquette ACM Programming Competition. This one is called Bend Around the Block, and this one gives you two 2D figures that are side views of an assembly of blocks. So you're going to have some sort of block building of just blocks on a coordinate plane, and we're going to be giving you a front view and a right view of that building. So we're going to essentially see towers of blocks in a line. And from that, we need to figure out the minimum number and the maximum number of blocks to assemble buildings that will yield those views, those front views and those right views. So let me explain this a little bit more using this tool that I found online. So I've modified the test figures that were given to you in the problem write-ups. So for example, this is one front view that you could have, and in number form this is just given by the height of each tower. So in the input we'll receive a line that says 2, 0, 3, 1, 1, 1. So this is just 6 wide, and those are the heights of each tower. So the green is the front view. Then we have the right view, which is 1, 1, 2, 2, 2, 3. That's what they'll be giving you. Okay, so now let's go into the code and just set up the input to start with. Then we'll start talking about how do we find the minimum number and the maximum number of blocks needed to create these structures. Alright, so we're definitely going to be starting with just receiving input, so we'll need our scanner. We can just do this in the same way that we've done the past 5 problems. The first line is still going to be the number of test cases. We can use that with scanner.kb.nextInt. That'll give us the number of test cases, and we can loop through each test case using the same loop that we've been using for the other problems. This will just loop through once for each test case. Alright, so for each test case, the first line will give you the side length of each figure. So each block or each building is going to be on a square base essentially. And the side length of that square is the first thing that we give you. Then on the next line will come the front view line of heights, and then the right view line of heights. So the best way that I've thought of to store these sort of values is just simply in an int array. So we'll just have an array called front, which will store the heights of the front towers. So the length of this array will be the length of the side, which we've already found as side length. Alright, and the same thing for the right side. We're just going to store this in an array, and the array length is still just going to be side length. Now we can accept the input and put these into the array. So for each integer in the array, we're now going to take in the input and store it in the correct slot of the array. So we can say the front slot of the array of that tower in the array is what we receive next. Then we can do the same for the next line, which gives us the right side. So then the right side for each tower will just input the side length. So this is how we are going to store our views. Alright, so now this program will come in 2 steps. First we'll figure out the maximum number of blocks that we need to build a building that will give these views. Then we need the minimum number of blocks. So we'll just divide our code up. We'll start with the maximum, and then we'll move on to the minimum, just like that. Okay, so we've jumped back over to our 3D block builder. So to find the maximum building, the conceptual idea is that we're going to take one side of our building, so we'll just say the right side in this case, and we're going to copy and paste it to all of the different columns that we see on the front side, like this. Now obviously this hasn't quite lined up yet because we can see orange blocks behind and above the green blocks. So the idea for the maximum building is that we're going to take each green tower and cut off any blocks that are hiding above it. So in this case, that would be this block here for the one on the right. And now you can see that this row has been cut off at the height of 2. Every column here has a height of 2. And we're just going to go down the line and do that. So here we have a green tower of height 0, which means that we're basically going to cut off every single block that we see here. So this entire row has been cleared out because the green tower has a height of 0. Then we can move on to 3. We can see that there are no blocks above 3, so we're not going to actually cut anything off. That row is going to remain the same, looking as our blue. Okay, so that concept is sound. How do we do this in a program? How do we do this algorithmically? Well, the idea is that we're going to step through in a loop each green column. Then within each step of the green column, we're going to have to step through each blue column. And we're basically going to say, okay, what is the minimum height of the green tower that we're looking at and the blue tower that we're looking at? Whatever the minimum between those two heights is, that's what the height of that coordinate is going to be. So let's do a couple examples. So now we're on to this green block right here. I'll just put a marker right there. So we're going to step through each blue block. So let's start with this one. So the minimum of 1 and 1 is just plain 1. They're the same. So the height of that tower, is just going to be 1. So we'll just put 1 block right there. Then we move on to the next blue one. 1 and 1 again. So the height of that block right there is just going to be 1. Okay, then we move on to the next one. We've got a 2 height and a 1 height. The minimum of those two is 1. So we're going to have to cut this one off and say, okay, the block right there is only going to be 1 height. And we just keep going down the line and do that. So let's just finish doing this blue run. So we've got 2 and 1, that becomes 1. 2 and 1, that becomes 1. Then we have a 3 and our 1, so that becomes 1. There we go, so we finished that row. And then we're going to do that for the next one. And we're essentially going to algorithmically continue cutting off these blocks. So this is the maximum building for these two figures, like that. Alright, so now let's do this in code. So we're going to have to keep track of the total maximum number of blocks. So we're going to be looping through every single tower and point in our coordinate system, and every time we're going to be adding to this total value essentially. So this will be the max building total, the total number of blocks that we need to make the max building. And it's going to start at 0 and we'll slowly build on that number. So like I said, we're going to loop through each green block. So we can do that with this for loop syntax. If you haven't seen this, this is basically looping through every integer that we have in our front integer array, and inside the for loop we'll just reference it using this f variable right here. All you need to know is that it's looping through every single green value in order. Then we'll be looping through every single blue value, like I said, for every single green value. So now we basically have a point on our grid, and we're going to say, like we said, we're going to add to the max total the tower at that point. And the tower at that point is going to be the minimum between the green and the blue tower that we're looking at. So we're going to take the minimum of our green tower that we're looking at and the blue tower that we're looking at, and that's the number of blocks that we're going to add at that point. And as we go through the for loop, it'll add up to be our max total. So by the time we get to this point in our code, the max total will be the correct maximum building number of blocks. Alright, so now we're going to move on to count the minimum number of blocks that we need to make our building with to still get these side views and front views. So this one's a little bit more challenging than the maximum. Instead of looping through every single tower, like tower index like we did with the maximum, we're going to actually have to loop through every single height that we get. So there's only 3 heights that we encounter in this problem setup. We've got a height of 1, a height of 2, and a height of 3. So this one's going to require a little bit more storage and manipulation to get right. So let me explain the conceptual idea for the solution for this problem to start with. So like I said, we're going to be looping through every single tower height. So let's just start with a height of 1. Over here we've got 3 towers on the green side that have a height of 1, and 2 towers on the blue side that have a height of 1. The idea is that for the minimum building, we're going to have to distribute the bigger number of towers among the smaller number of towers. In this case, we'll be distributing 3 greens of height 1 over 2 blues of height 1. So that could look something like this. So we took those 3, and each of them has a green column, and we distributed them among the 2 blue column rows. And so the distribution could look something like this. We can even shift them around a bit. It does not matter. So long as we get 1 green, or 1 block on each green and 1 block on each blue, we'll have the minimum number. So ultimately, the number of orange blocks that we get for each tower height is the maximum between the number of that tower height we have on the blue and the number of tower height that we have on the green. So in this case, we look at, okay, we've got 3 greens that have a height of 1, 2 blues that have a height of 1. So the maximum that we need is 3. And the 3, then we multiply by the tower height, in this case is 1, so we just get 3 back. So we're going to add that to the total. We add 3 to the total because we have 3 as our maximum number of towers multiplied by 1 block for each tower. Maybe this will make a little bit more sense as we do more examples. So let's move on to now a tower height of 2. Over here we got 1 2-height green tower, but 3 blue towers with 2 height. So we're going to have to distribute these 3 blue 2 height towers among this 1 green height tower. There's only one way to do this in this case. We just have to put them all in a row behind the green block. But as you can see, our algorithm sort of still works out. We're going to take the maximum between these two. So over here we got 3 towers, and over here we have 1 tower. So the maximum is 3, and we take that 3 and we multiply it by the tower height, and we end up with 6 blocks to make our minimum. All right, and then let's finish off by doing our 3. So we've got 1 3 here and 1 3 tower here. So we're going to have the maximum of those two is 1. 1 times 3 is going to be a minimum of 3 blocks to make that figure. So this is one example of the minimum building, and we found out that it was 3 from the 1 height, 6 from the 2 height, 3 from the 1 height. We add those up, or 1 from the 3 height, 3 from the 3 height, and we add those up, and that'll give us the total minimum number of blocks. So let's go over and put this into code now. Okay, so we're going to implement the minimum height in code now. Like I said, instead of looping through each tower this time, we're going to be looping through each tower height. So the new sort of maximum that we need, before our like loop length was the side length. Now our loop length is going to be the biggest tower. So over in our example here, our maximum height was 3. So we only had 3 loops that we had to go through. So we need to find the maximum height between our two facings. We need the maximum tower height, essentially. So let's store that once we find it in some sort of variable. We'll start it at 0, and then we'll simply just look through one of the sides looking for the biggest tower. So we'll loop through, let's just say the front. And we'll say, okay, what is the biggest height? And we can do that by saying, okay, if the current tower that we're looking at is bigger than any other tower that we've checked so far, then that becomes the new maximum tower height. So all this loop is doing here is finding the biggest tower in our problem. So in our example problem, it'll come up with a maximum tower height of 3. All right, so like I said, we need this maximum tower height because our loop length is going to change. So we're now worried about the number of towers for each tower height. So we're going to need some new arrays that contain, for each tower height, the number of that tower height. So we're going to have the number of, say, 1, 2, and 3 height towers in the front, and the number of 1, 2, and 3 height towers in the right. So we're going to have 2 different arrays, and the length of those arrays will be that tower height that we found. Just like that. Now, since arrays are 0 base indexed, let's just increase this by 1. That way, for convenience sake, index 1 will refer to the number of 1 height towers rather than having to worry about index base 0. That'll just make things a little bit more convenient for our code. All right, so now we need to actually fill these arrays. We need to figure out how many of each tower height do we have. So we can simply do that by looping through each face and saying, okay, this tower, how high is it? And then we'll go to that index in the respective array and increase that count by 1. So we'll go to, let's say that this is the current f that we're looking at is a height of 2. Then we'll go to the 2 index in our front count array and increase it by 1. We're saying, okay, add 1 to that count. We've found one more 2 height tower. And we'll do the same for our right face. We'll loop through each tower and we'll say, okay, how high are you? And then that height gets increased by a count of 1. All right, so all these loops did was count up how many of each tower height do we have on the front face and the right face. So in our example, it'll come up with 3 for index 1 on the front, 1 for index 2 on the front, and 1 for index 3 on the front. And then for the right, we'll have 2 in index 1, 3 in index 2, and 1 in index 3. We're just storing the number of that specific tower. All right, so now we're going to actually do our counting algorithm. So once again, just like we did up here with max total, we're going to need some total to add as we figure out the number of blocks. We're counting up these blocks. We need to have a variable that we can add these numbers to as we find them. So we're going to start with tower height 1 and loop through every tower height. So let's just say our current tower height, so we're starting at 1 and we'll go until we reach the maximum tower height. So we'll say less than or equal to our max tower height. And then we're going to step through each tower height, so we'll just increase by 1 each time. So this loop is going to loop through each tower height. It'll go current tower height 1, current tower height 2, and current tower height 3, as in our example. What do we do once we get there? Well, like we discussed, we need to add to the min total the maximum count of that specific tower. So in the case of the greens here, we've got 3 green, 3 one height towers for green, and 2 one height towers for blue. So the maximum in this case is 3, and then we'll multiply that 3 by that height of the tower, so 1 in this case. So we're going to add to the total the maximum count of green. So we'll take front count and we're accessing the current tower height index. So this array call will turn 3 in our case for green 1 tower heights. And then we'll do the same thing for blue. So we're just finding, okay, 1 tower heights, how many are there? What's the maximum of between green and blue? And we're going to multiply this by the current tower height. That way, each tower that we make in orange is going to have that many blocks. So for 1, it'll be 1 block each. 2, it'll be 2 blocks each. And we'll add that to the min total. So once this loops through, this is going to follow our algorithm that we figured out before and count up how many blocks you need minimum to make a building that will give these 2 front faces. All we have to do next is print out the solution. So we can just put this right into a print line. All we have to do is print the minimum, then put a space, and then print the maximum. We called these max total and min total for our variable names. All right, so let's go and use the test case that we've been building. So we're going to have 1 test case, and then the side length for our grid is going to be 6. So our front face, if you remember, was a 2, and then a 0, and then a 3, and then 3 1s. And then the right blue face was a 1, a 1, 2, 2, 2, and then a 3. So this got a minimum of 12 and a maximum of 39. Let's see if that's right. So the minimum, yep, we've got 12 blocks among here for the minimum. All right, and then this is the maximum building that we came up with. And we count these up. These are 39 blocks. So this is the correct implementation for bend around the block.